All right, so welcome back for our last topic here in Unit 7, our product angle identities. The two different types of product angles we're going to take a look at, the product to sum and then the sum to product. So product to sum is dealing with how we're multiplying sine and cosine in different combinations. So sine times sine, sine times cosine, cosine times cosine, and then cosine times sine. These two right here are actually kind of interesting, simply because the order of multiplication doesn't actually matter. So the fact that they are using two different results is interesting there. But you would find if you did switch around, you would get the exact same expressions. Just kind of the trick of how the angle's working. Noticing right here, the difference here, yielding a plus versus a minus sign, telling me something about the order of the angles and what's going to happen there in terms of one being larger than the other, negative angle identities. So we're writing here this one, so we'll recognize this giving us our order is sine times cosine. So we're going to use our sine A cosine B formula right here. The negative 4 that's going to multiply in front, we're going to do that times the whole thing. So it's negative 4 times. Each one of them is a 1/2. And then if we're doing sine A cosine B, it's sine where we add the angles together, 74 plus 68. And then plus sine where we then subtract them, 74 minus 68. The negative 4 on the outside gives us a negative 2. Adding 74 and 68 is going to give us a 142. And subtracting 74 and 68 gives us a 6. So we can leave it in that kind of form right there. Or we can go ahead and distribute the negative 2 to both of them. Say negative 2 sine 142 minus 2 sine 6. Both answers are perfectly acceptable. It just kind of depends on your own personal preference for how you want to write them. And that's really all these are going to be. For the most part, they're not going to be anything too hard from there as long as you apply the formula correctly. The biggest thing is being careful with when you're doing the A minus B portion, that if you get a negative angle to rewrite as a positive angle and only using our positive angle arguments. So here, this is our cosine A sine B formula. So this is now, again, the 5 on the outside, 1/2. And then we're doing sine of the two angles added together. So this one's algebraic, but it's still the same process, 3x plus 8x. Then minus sine of 3x minus 8x now. So we're going to see that we get 5/2 on the outside. This becomes sine of 11x minus sine of negative 5x. Again, negative angles not allowed, so we're going to pull it out for sine. And if I distribute, so I'm going to typically distribute, I'm going to get 5/2 sine 11x, then plus 5/2 sine of 5x. Okay, so it's all about taking the negative out of the expression there. And then since it's being taken out, there was already a negative there, that's why it became a plus sign. All right, so this is our sine A, sine B. So we're multiplying two sines together. Our formula tells us, well, there's no coefficient in front this time, so just 1/2. And then we have cosine of A minus B. So cosine of 5 minus 174 minus cosine of A plus B, so 5 plus 174. So we get a 1/2 cosine of a negative 169 minus cosine of a positive 179. Sine the negative was pulled out, but cosine the negative just cancels. So really just is going to be 1/2 cosine of 169 minus 1/2 cosine of 179. So the negative just goes away. It's not part of the problem anymore when it's cosine of the negative angle. And then our last one, so since there's 4 possibilities, we're going to take a look at 4 of each. We have this one's our cosine A, cosine B formula. So for this one, again, there's no coefficient in front, so we'll just have it as 1/2. And then it's going to be cosine of A minus B, so 5x minus 12x. And then plus cosine of A plus B, so plus cosine of 5x plus 12x. So we get 1/2 cosine of negative 7x. And then plus cosine of 17x. Again, the negative for the cosine doesn't matter, so just 1/2 cosine of 7x plus 1/2 cosine of 17x. All right, so that is our product to sum identities. Nothing too crazy right there. Simple substitute into it. As long as you're careful with your negative angle identities for when that occurs, because you're doing A minus B, that's going to occur statistically half the time. You just got to watch out. So then we also have our sum to product here. So we're doing sine plus sine, sine minus sine, cosine plus cosine, or cosine minus sine. We yield these four different formulas. There's a 2 out in front of each of them, though notice the last one, cosine A minus cosine B, there's a negative 2. All right, and then like with the previous problems here, if you get a negative angle inside from doing the difference, then you are going to have to factor the negative out for the sine, or just cancel it for cosine. So first up, we have cosine plus cosine. So this is the cosine A plus cosine B formula. It tells us we're doing 2 cosine A plus B over 2, so 3x plus 7x over 2, and then cosine of A minus B over 2, so 3x minus 7x over 2. So we get 2 cosine, 3 plus 7 is 10 over 2 is 5, and then 3 minus 7 is negative 4 over 2 is negative 2. Again, the negative cancels, so we're just left with 2 cosine 5x cosine 2x. And that's just our final results. Not doing anything else with the problem, just simply working through the formula and then simplifying it down to get to our final results. If you notice that they both have coefficients, for this to work, they have to have the same number. So we can factor it out, saying it's 3 sine 16x minus sine 2x. So this is our sine A minus sine B formula. So you'd have a 3, and then the sine A minus sine B is 2 cosine of A plus B over 2, so 16x plus 2x over 2. And then sine A minus B over 2, so 16x minus 2x over 2. We get 6 cosine of 16 plus 2 is 18 over 2 is 9, so 9x. And then sine 16 minus 2 is 14, divided by 2 is 7, so 7x. And there's nothing else to do with that. There are no negative angles. That's not going to always happen with a negative when you're doing the A minus B over 2 portion. So that's just our answer. 3 times the 2 in front, and then your difference, cosine sines, all you're doing is applying the appropriate formula. This one, again, after we factor the 4 out in front, we yield a sine A plus sine B equation. And again, for this to work, it's always going to be the same number. You can't have a situation where there's a 4 and then a 3 and then still apply your sum or difference identities. That's not going to work out for the problem there. So sine A plus sine B, we have our 4 in front, then a 2. And then it's sine of A plus B, so 82 plus 108 divided by 2. And then cosine of A minus B over 2, so 82 minus 108 divided by 2. We get 8 sine. When we add 82 and 108 together, we get 190. Dividing that by 2 gives us 95, so it's sine 95. As for the cosine portion, the 82 minus 108 is negative 26, divided by 2 is negative 13. Can't leave as a negative angle, so we take its, well, it's cosine, so it's just canceled. So we have 8 sine 95, cosine of 13, and that's our answer. We got one more to go because we have one more formula. I guess one thing to comment is if any of these angles happen to create unit circle angles, then you could evaluate that particular portion a little bit further. But that would be the extent of what these problems can do. That would be, again, possible, but not exactly a common occurrence when you're working through these problems. So as our final one, there's no number to factor out. This is clearly our cosine A minus cosine B formula. So we're setting up, it's now a negative 2 out in front, sine of A plus B, so sine of 221 plus 75 over 2, and then sine of A minus B, so 221 minus 75 all over 2. So our 221 plus the 75 is 296, divided by 2 is 148, so sine of 148. And then for the other one, the 221 minus 75 is 146, divided by 2 is 73, so sine of 73. Neither angle is negative. Nothing more I have to do there. All right, so that's the last of our different trig angle identities. Actually, that's the last of our trig units. We're still going to use trig throughout the year at different points. You'll see it popping up when we take a look at our polar functions in Unit 10. So you get a little break from trig with the next 2 units with matrices in Unit 9 and then the conic equations in Units 8, but they will pop up again, so don't forget your trig abilities. Alright, so I'll see everyone next time for those future videos.